Okay, this is paper 2 for the examination from 2022. This is specimen paper 2. Look at the page 2. So this is the data given. Acceleration of the free fall, speed of light, elementary charge, mean the charge of the electron, charge of the proton, then atomic mass unit, U, mean the mass of the proton or the mass of the neutron inside the nucleus, and then the mass of the proton outside the nucleus. This is the mass of the electron, then Avogadro's constant, then molar gas constant, then Boltzmann constant, then gravitational constant, then permittivity of the free space, then Planck constant, and Stefan-Boltzmann constant. So for the paper 2, this is required, speed required, charge required, this 1U mass required, then m electron. So these are the requirements. And then look at the formula. Only these formulas will be given from 2022 in the sheet. This second equation of motion, third equation of motion, pressure rho gh, and upthrust formula rho g into volume v, and this Doppler's effect formula, frequency, observed frequency, and the current, then resistors in series and the resistors in parallel. Rest of the formula you have to learn. Okay, only these formulas will be given for the paper 2 and paper 1. Now move to question number 1. The speed v of the transverse wave on the uniform string is given by the expression v is equal to under root T L over m, where T is the tension in the spring, L is the length, and m is the mass. An experiment is performed to determine the speed v of the wire. The measurements are shown in the table. T given 1.8 Newton plus minus 5%, then length given 126 centimeter and plus minus 1%. So the tension is 5% and the length is 1%. Then the mass is in gram 5.1 and plus minus 2%. Use the data in the table to calculate the speed v. Okay, look at the formula. V is equal to under root T over TL over M. So V is equal to under root TL over M. Now substitute the values. Under root, tension is 1.8, and this length 126 centimeter, but in meter, it will be 1.26 divided by mass in kilogram, 5.1 into 10 power minus 3. And after calculation, the answer will be, okay, after calculation, 1.8 times 1.26 divided by 5.1, 10 power minus 3, and then under root, the answer is coming 21. So we have to write answer in 2 significant figure, because this is 2 significant, this is 3 significant, this is 2. So due to different significant, we have to write the answer. We have to quote the answer in minimum significant use. The minimum are 2, so answer is 2. Next, use the answer in A and the table to calculate the absolute uncertainty in the value of V. Look, the percentage uncertainty of each is given. So from the formula, V is equal to TL over M under root, mean it is T power 1 by 2, it is L power 1 by 2, this is M power 1 by 2, whole power is 1 by 2. So the percentage uncertainty of the V is equal to 1 by 2 times percentage of T plus 1 by 2 times percentage of L plus 1 by 2 times percentage of M. So we can write it 1 by 2 common, then T percentage is given 5, length percentage is given 1, and the mass percentage is given 4. So this is 2, sorry, this is 2. So this is 8 divided by 2. So this is 4%. Now, the percentage uncertainty in V is 4%. So we have to calculate the actual uncertainty. It is the 4% of the answer of V, which is 21. So 4 divided by 100 times 21. So it is 0.84, but the answer of the error is always quoted in one significant figure, so plus minus 0.8. So look at the question again. So first you have to calculate the speed from the formula, and then by using the percentage uncertainty, we will calculate the total percentage in V, and then 4% of 21. Look, this power under root mean is 1 by 2, so it becomes the power of each, but during percentage, it becomes a multiple. 1 by 2 times the percentage of T, 1 by 2 percentage of L, 1 by 2 percentage of the M. Now, the next question is define acceleration. So the answer is rate of change of velocity is called acceleration. Or you can write the change of velocity per unit time is called acceleration. Now the next question is about the projectile motion. The ball is kicked from the horizontal ground towards the vertical ball. The horizontal distance between the initial position of the ball and the base of the wall is 24 meters. It's given here. This is the horizontal distance. The ball is kicked with the velocity v at the angle of 28 to the horizontal. The ball hits the top of the wall after 1.5 seconds. Air resistance negligible. Calculate the initial horizontal component Vx of the velocity of the ball. Okay, so the formula for the Vx, which is very common, is V cos theta. But the problem is the velocity, the resultant velocity with which it's thrown, it's not mentioned here. So we can't use this formula. Now look, horizontal distance is given, and the horizontal distance is covered due to horizontal component of the velocity, number one. And number two, due to negligible air resistance, there is no horizontal force acting on the object. So when no horizontal force, no horizontal acceleration, it means then the horizontal velocity Vx is constant. So if the velocity is constant, then the formula is distance speed into time. So this is the horizontal distance, so horizontal velocity. So we can write horizontal velocity is horizontal distance divided by time. Horizontal distance covered is 24, and time taken to cover this distance is mentioned here 1.5. So 24 divided by 1.5, the answer is coming 16. So we have to quote it in two significant figures. Okay, look, velocity is constant. This horizontal component of the velocity is constant because in the absence of air, no horizontal force acting on the object. So the constant velocity multiplied by time is distance. So this formula is only used when the speed velocity is constant. So horizontal distance, horizontal component of velocity into time. So this is the answer. Show that the initial vertical component of the velocity is 8.5. Again, the famous one is Vy is equal to V sine theta, but we have no value for the V. So we will try the other formula. Look, the relation between the vertical component and the horizontal component is tan theta, because this is horizontal velocity, this is vertical velocity. When both are added, head to tail rule, this is the resultant velocity. So this is a right angle triangle. So we can use Pythagoras theorem, perpendicular square plus base square is equal to this hypotenuse square. But here, this Vy is required. This is given. This Vx is given. This angle is given. So we can write perpendicular over base tan theta. So same here, perpendicular Vy divided by base Vx is equal to tan theta. So Vy is equal to Vx tan theta. Vx is calculated 16 and tan of, look, the angle is 28 degree. So the 28, tan of 28 multiplied by 16, after calculation, the answer is coming same, 8.5. Next, calculate the time taken for the ball to reach its maximum height above the ground. So the maximum height is this. And the vertical height is covered due to the vertical velocity. Horizontal distance is covered due to horizontal velocity, and the vertical distance means the height is covered due to the vertical component of velocity, but the vertical component of velocity is not constant. Reason, because the weight is acting there. Due to the weight, acceleration due to gravity is there. So initially, the vertical velocity is this, and we have calculated this 8.5 here. And here, the vertical component Vy becomes 0. So calculate the time taken. So first equation of motion, V is equal to U plus AT. Final vertical velocity at the top is 0. And the initial vertical velocity, we have calculated 8.5. And for the upward journey, this acceleration is minus G in the equation 9.81. And the time is required. So minus 8.5 is minus 9.81 into t, minus cancelled. So time is equal to 0.85 divided by 9.81. And after the calculation, your answer will be 0.866, means 0.87 into significant figure. And there is another method. You can write direct formula. So in projectile, from bottom to top or top to bottom, the time is V sine theta over G. So same here, V sine theta is Vy, so which is 8.5 divided by 9.81. So you will get the same answer. So this formula is derived from this first equation. Now the next, the ball is kicked at the time 0, assuming that the vertical component Vy of the velocity of the ball is positive in the upward direction. On the figure, sketch the variation with time t of the Vy for the time. So we have to plot the graph for the Vy. Look, initially we have this vertical component velocity 8.5. So look at 8.5 initially. So this is 5, this is 6, 7, 8, this is the point. And then after 0.87, it becomes 0. At the top, the vertical velocity becomes 0. So after 0.7 seconds. So this is 0.8, 0.82, 0.84, 0.86, and this is 0.8. So approximately, this is the point at which the velocity becomes 0. And then now look here. So we have to plot the graph, sketch the graph Ty for the time until it hits the wall. So this ball is hitting the wall after 1.5 seconds. Mean this is 1.4, 1.6. So this is the end. So beyond this, no graph required. Now, for the upward journey, the acceleration is 9.81. For the downward journey, it's 9.81. It means the gradient of the velocity time graph is constant. So by using the scale, we have to draw here a line. The gradient must be the same because acceleration is constant, free fall acceleration. So the line is this. Up to this point. So this is the line for the graph. And then calculate the maximum height above the ground of the ball, maximum height. So you have option, you have choice. Either use the direct formula, h is equal to v sine theta whole square over 2g. So here, v sine theta is vy, which is 8.5 square divided by 2 divided by 9.81. And you will get answer this 3.7 approximately meter. Or you can use equation v square is equal to u square plus 2as. So the final vertical velocity is 0. The initial vertical velocity is 8.5 plus 2. For the upward journey, the acceleration is minus 9.81 and the distance covered is h. So minus 8.5 square is equal to minus 2 times 9.81 into h, minus cancelled. So h is equal to 8.5 square divided by 2 divided by 9.81. So it's similar to this calculation. So you will get the same answer, 3.7 into significant figure. And the next. The question is the maximum gravitational potential energy of the ball above the ground is 22 joule. Calculate the mass of the spring. So look, gravitational potential energy formula is mgh and energy is given. So 22, mass required g 9.81 and the height, yes, is calculated 3.7. So the answer is m is equal to 22 divided by 9.81 divided by 3.7. After the calculation, 22 divided by 9.3.7, answer is coming 0.61. Approximately 0.61. We have to write the answer in two significant figure. Next, a ball of the greater mass is kicked with the same velocity as the ball in B. Air resistance still negligible. Important information. State and explain the effect, if any, of the increased mass on the time taken by the ball to reach the maximum height. Look, when air resistance is negligible, mean in the absence of air resistance, acceleration is g, which is constant. Thus, no effect on time because the acceleration is constant. So for the small mass, for the more mass, the acceleration of the free fall is same in the absence, so no effect on the time. Next question is define force. So simple is rate of change of momentum is called force. State what is meant by the work done. Look, 1 mark. You can write the meaning, you can write definition, it's up to you, but the 1 mark acceptable. So either write when force is applied on the object and distance is covered in the direction of force, then work is said to be done. Work is done. But for the 1 mark, the meaning of the work can also be written as, in terms of the definition, product of force and linear distance in the direction of force is also called work. So you have a choice. Either write when force is applied on the object and the distance is covered in the direction of force, then the work is said to be done. Or in short, the product of force and the linear distance covered in the direction of force is called work. Next, the block of the mass 0.4 kg slides in a straight line with a constant speed of 3 meters per second along the horizontal surface, assuming that there is no resistive force opposing the motion of the block hits the spring and decelerates. The speed of the block becomes 0 when the compression of the spring is 8 centimeters. Calculate the kinetic energy. So the formula first, kinetic energy is equal to 1 by 2 mv square. So 1 by 2, look at the mass, it's 0.4. Multiply by speed square. Speed is 0.30 and it's square. So 0.30 square multiplied by 0.4 divided by 2, the answer is coming 0.018, mean it is 1.8 into 10 power minus 2. So 1.8 into 10 power minus 2 joules. Next, the variation of the compression X of the spring with the force F applied to the spring is shown in the figure, assuming that the elastic potential energy of the spring when its compression is 8 centimeters is equal to initial kinetic energy. Important information. Use the answer in B1 to calculate the maximum force exerted on the spring by the blocks. Look, it is mentioned that elastic potential energy and kinetic energy both are equal, and the kinetic energy we have calculated in the previous part is 1.8 into 10 power minus 2, and from the graph the area is a strain energy, elastic potential energy, so it is 1 by 2 F into X. So 1.8 into 10 power minus 2, 1 by 2, the force is required, and this compression deformation is 8 centimeters, mean 8 into 10 power minus 2. So this 10 power minus 2 cancel both sides, then 1.8 multiplied by 2 divided by 8 is the maximum force, and after calculation, so this is 0.45 Newton. So you have to mention this. Calculate the maximum deceleration of the block. Look, F is equal to MA, then A is equal to F divided by M. F force calculated 0.45 and divided by mass, the mass is 0.4. So 0.45 divided by 40, the answer will be 1.1 meter per second square, too significant figure. And the next is state and explain whether the block is in equilibrium before it hits the spring. So before hitting the spring, look at the statement. The speed of the block is constant. Its direction fixed, speed fixed, mean the velocity is constant. So we will write here, due to constant velocity, acceleration is 0, resultant force 0, thus object at the block is in the state of equilibrium. Constant velocity, acceleration 0, because no change of the velocity, the resultant force 0, so equilibrium. And then when its speed becomes 0. So look, we have already calculated the deceleration. So the answer is due to retardation, the resultant force is not 0, because there's a retardation, negative acceleration. Hence, object is not in the state of equilibrium. And the next is the block is now replaced by another block of the same mass. The frictional force affect the motion of this block so that it has a speed of 0.25 when it makes contact with the spring. So this speed, this velocity is in this direction. A short time later, the block has a speed of 0.15 as it loses contact with the spring and moves back, mean this is the direction. So if this direction is taken positive, then this will be negative. So one positive velocity, other negative velocity. Calculate the magnitude of the change of the momentum. So the change of the momentum is the final momentum minus initial momentum, m common v minus u. So look, m block mass 0.40. The final velocity is this minus 0.15 because the opposite direction, and this formula sign minus here, and then u is 0.25. This minus is due to this formula, not of the direction. So 0.40, and both are added, then it is also 0.40. So we can write 0.40 into 0.40, so 0.16. So this is the change of the momentum. It's up to you, positive, negative sign mentioned or not, but this is the sufficient answer. Okay, so these are the few questions.